This is Mr. Hannon. Welcome to What the Format. Today we're going to go over difference of squares. A squared minus b squared. What does that mean? Well, it means you have the difference, first of all, subtraction. Squares means you have a number that was squared and a number that was squared. So to factor it, you basically take the square root of a and the square root of b, and then you do 1 plus and 1 minus. Now, when you have these are called conjugates. And conjugates are used a lot in algebra. Okay, so let's go over a couple examples. Let's say I have 9x squared minus 16. So the first thing I look for is the fact that it's a binomial. Difference of squares always has two terms. Then I look at the middle. It needs to be a minus. Now I look at the front and the back. They need to be perfect squares. So 9x squared, the square root is 3x. 16, the square root is 4. And remember, I do 1 plus. So there's a 3x plus 4, and then I do 1 minus. And that's how you factor difference of squares. Now, of course, a lot of times they like to combine it. So for instance, let's say I do 50x squared minus 72. All right? Now, x squared is a perfect square. This is a minus. It's a binomial, so you're thinking perfect square. But then when you look, 72 and 50, those aren't perfect squares. However, they both have a what in common? 2. So if I factor the 2 out, I'm going to get 25x squared minus 36. So greatest common factor, once it's out, now I have difference of squares. So I'm going to put the 2 there. Square root of 25x squared is 5x. Square root of 36 is 6. We do 1 plus, and then we do 1 minus. And that's how you factor difference of squares. This is when you have more steps than just factoring once. So here we just had to factor one time. Here we had to factor twice. The greatest common factor had to come out first. Once the greatest common factor is out, then we factor the difference of squares. Now this is a pattern that both forward and backwards. If you multiply a plus b times a minus b, you multiply conjugates. Notice the middle term goes away. Well, why? Well, that's minus ab plus ab. When you have opposites, they always add to 0. So very important pattern in quadratics and in polynomials, and they're not always quadratics. I mean, these could be to the fourth, x could be to the fourth power, because remember the square root of x to the fourth is x squared. You could have another variable here. I could put a y squared here, and then you just would have put a y and a y there. So there's lots of different ways they hit. What you want to look for difference of squares is that there's a minus in the middle. It's 2 terms, and these 2 terms are perfect squares. You can take the square root of them. If you can't, like I said, you look here, always check for greatest common factor. Now sometimes they'll throw one of these out and you'll think you should be able to factor it, but then you can't, so it'll be prime. So don't be surprised if once in a while you get that. If I were seeing a test on difference of squares, I would expect at least 1 or 2 of them to be prime. I would expect some greatest common factor in there, sometimes even with an extra variable in there. Make this x cubed, put an x there, so then you would have a 2x that came out or something like that. But now, so when you start to see all these variations, how many different possibilities there are. That's why you need to be very good at identifying and looking at what you're dealing with, so you can see these little anomalies that when they appear, mainly you can see the main pattern, and then you can also see some additions or little things they tweak to it. That's where a lot of students get in trouble. They think they've got it, they get to the test, and then they see some things they didn't expect, and their brains panic. This is why you need to memorize some basic things and then practice a lot of them. If I were doing difference of squares, for instance, and I wanted to get ready for a test, I would look at 50 to 60 examples. And you know, you're thinking, well, that's a lot. But here's the thing is, once you get past the first 4 or 5 and start to get a rhythm, it actually becomes pretty quick. And you can actually do 50 or 60 problems in about 20 minutes. And then if you see a wide enough spread, a variation of these and the different tricks they pull, then you're ready for the test. If you only do 3 or 4 and you think, oh, this is easy, well, then something like the greatest common factor here with either numbers or variables will catch you and you won't be ready for it. But anyway, this is the difference of squares. Hopefully this helps with that. Again, once you understand it or start to understand it, practicing problems is always good. The more you practice, the better you get. This has been Mr. Hanna with What the Format. Thank you for watching and happy mathing.